Hello, welcome to this lecture. We have got a talk on Brewster's law, polarization by reflection. So we have got so many methods where we can produce polarized light by unpolarized light. One of the methods where we can produce is by reflection. So it is a phenomenon in which when the light incident on a certain medium from one more medium, this is actually rarer medium for example, this is actually denser medium, and the light will get reflected to the same medium. So this has got refractive index n1 and this has got refractive index n2, and this is unpolarized light which has vibration in all the directions. Okay, this is unpolarized light which will be incident on the surface, and a part of the unpolarized light will be reflected. Okay, and another part of the light will be refracted, or I'll draw a normal here to the surface. And when the light travels from the rarer to denser, if it is a case of refraction, it bends towards the normal. Okay, so this is refracted ray. Now reflected ray can be polarized, and the amount or the degree of polarization depends on the angle of incidence. So if you keep on increasing the angle of incidence, the amount of polarization will increase. But at certain angle of incidence, I call it as theta p, we call it as a Brewster's angle. Okay, Brewster's angle, the reflected ray is completely polarized. That means vibration will be confined to the only one plane. Okay, so here it's an unpolarized light which is incident, and a part of the unpolarized light will be reflected. This is actually reflected polarized light which is completely polarized for certain angle of incident. We call it as Brewster's angle theta p. And what law of reflection says is angle of reflection and angle of incident are same, that is theta p. Okay, and this is nothing but r, which is angle of refraction, and n1 is refractive index of the rarer medium. It could be air medium, or if it is a case of air medium, obviously it is 1. A denser medium, refractive index is n2. It could be water, 1.33. If it is a glass, 1.5. So anyway, there is a difference refractive indices for two different mediums. Now the Brewster's law says, what Brewster's law says is the refractive index of the denser medium is actually equal to tangent of angle of incidence theta p, and we can prove this. What we can do is see, I've already told you, for certain angle of incidence we call it as Brewster's angle theta p. The reflected ray is completely polarized. One more condition for this angle of incidence in which the reflected ray is completely polarized, the angle between reflected and refracted ray is always 90 degree. So for a Brewster's angle, the angle between reflected and refracted ray is 90 degree. I mean when the reflected is completely polarized, obviously they are perpendicular to each other. So if I consider this plane only, okay, this is a plane, the whole angle is 180. So sum of theta p and 90 and r is just equal to 180, because you have considered the whole plane 180 degree, theta p plus 90 plus r, where theta p is angle of reflection, or we can say that it is a Brewster's angle. Again, it's angle of incident as well. R is angle of refraction. So I'll write for r is equal to 180 minus 90 is 90 minus theta p. This is just nothing but angle of refraction. Now what Snell's law says is, for the refraction, the ratio of refractive indices denser to rarer is just equal to sine of angle of incident to sine of angle of refraction. Now this is sine of angle of incidence is nothing but theta p. Now at this moment, sine of angle of refraction r is just 90 minus theta p. So this will be equal to sine theta p by cos theta p, which is equal to n2 by n1. So I got a relation n2 by n1 is equal to tan theta p. And this n1 is nothing but refractive index of rarer medium. Usually it has got value 1. If it is a case of air medium, obviously it is 1. So n2, let me simply say it's n, maybe a refractive index of water or glass. So this is n by 1 is equal to tan theta p, which implies tan theta p is equal to n. So this law is called Brewster's law. So theta p is actually nothing but Brewster's angle, in which the reflected ray is completely polarized, and as well as the angle between reflected and refracted rays 90 degree. So what law says is the tangent angle of incidence, we call it as a Brewster's angle, is exactly equal to a constant. That constant is nothing but refractive index of the denser medium, in which the reflected ray is completely polarized. Thank you for watching this.